Good afternoon, everyone. My name is Bart van der Sloot. Thank you for preferring us over a beer outside. I think this will be a pretty unique presentation because we seem to be the only people presenting from a non-Apple device, and I get slightly jealous in the course of the day. I will briefly take you through who Fibering are and the network that we're operating. Then Sam will take over and talk a little bit about the network management challenges we have and how we address these using open source tooling. And then I will come back at the end with some conclusions. Fibering is member of a Dutch holding company that has 4 operating companies. First company, and probably the best known and the biggest in the group, is LeaseWeb, one of the top 10 worldwide hosting companies, and now also running a portfolio of cloud and CDN services. The second is Data Center, a data center construction company, building modular and very energy efficient data centers. Third company in the group is EvoSwitch, which is actually a data center company running 2 data centers, one in Amsterdam and one in the east coast of the US. And the fourth company in the group is us. We're a network services provider, basically with a portfolio of services of everything you need to transport internet traffic. Now, the whole group has locations in Amsterdam, Frankfurt, US, East Coast, West Coast, Singapore, and soon also Hong Kong. And it's roughly 350 people with over 30 nationalities these days and over 60, 70 people in software development. So it's actually been growing pretty rapidly over the last 5 years. If you look at the network that we run, it basically reflects the history of the company. Company started in Amsterdam as a web hosting company. So what the group has been doing, of course, is to build a network to take that traffic to all European capitals and to connect there to all the eyeball networks, either through internet exchanges or through private peerings. And we've copied the same model in the US, so basically star architectures where to all the major internet hubs we have multiple 10 gig waves via diverse paths to bring the traffic as close as possible to those eyeballs. I'll give you some numbers. The total volume of traffic we manage is roughly 2.5 terabits per second. Most of that sits in what we call the LeaseWeb global backbone, AS16265, which is also here represented at the Plix Internet Exchange. We run more ASs, and we also manage some of the traffic for our customers. How do we distribute traffic? Well, as I already said, it's a mix of IP transit. We basically buy transit from all big global networks, which is over 10 providers. We have over 500 peers, of which 30 are private peers, and we're connected through 30 internet exchanges with all these other networks. And to distribute all that traffic, we have now 300 gig port at AM6, and soon we expect to be turning up the 4th 100 gig port at AM6, and also the first 100 gig port at DKIX. We have over 480 10 gig ports for peering and transit, and over 120 10 gig waves to transport all the traffic across the world. So you will imagine it's quite a challenge to manage that network and the traffic on it. So that's where I hand over to Sam, who will explain you how we do that.
Hello, everyone. My name is Samer Abdel-Hafez. I work in network design for Fibering and LeaseWeb. Given the challenges that Bart just described, we decided to do something, and what we try to do is based on open source tools. The challenges that we wanted to address, first of all, is the network monitoring, so everything that regards interface status, traffic utilization, interface up-down, and everything that regards, in general, a network alarming. Of course, this is very important because the amount of devices that we have is very large, and this causes us pretty much a lot of headache when choosing what software to utilize for this. Second challenge is the capacity planning. Given the dense traffic that we have that is growing at a rate of around 100, 120 gig per month, we need to be very careful on planning the capacity for the interconnection towards peers, carriers, internet exchanges, and everything else, because we risk to find ourselves in situation of congestion and of course with the delays that generally the delivery of new services take, this is quite bad. So accurate prediction is really needed. The third challenge is the attack detection. We are a hosting company. We have a lot of traffic and a lot of servers, and of course we originate and receive a lot of DDoS. Unfortunately, we can't just mitigate this. We can't prevent customers, dodgy customers or hacked boxes or services from the outside to attack our network or to attack from our network to the outside. So we need to choose very carefully the tools to prevent this to happen. And the last of the challenges is the backup of network configurations for all the devices that we have. The requirements that we defined for this are, first of all, it needs to be easy to use and to maintain. So upgrades needs to be applied in a very straightforward manner, because unfortunately we don't have system knowledge in our team, in the sense that we don't have dedicated people that maintain our infrastructure. And so it's done by our NOC in general, or by the design team, depending on the complexity of the task. So as easier and it is to maintain, the better it is for us. The scalability, as I was saying before, is another requirement. It needs to scale up to thousands and thousands of objects, especially for the network monitoring part. And the integration with internal system is very important, because we rely a lot on internal systems that are integrated with our sales process and register the amount of service we have and everything together. So if we can integrate these systems with what is currently developed in-house, we have a big advantage. The long life expectancy is another critical point for us, because we don't want to continue to upgrade the software or to change software every time that software gets dismissed or abandoned. We need to have something that lasts forever or for a long time, so we don't have to change it anytime soon. And the same is worth for updates. We need something that is updated regularly, because we of course focus on these tools. Why open source? Open source is cost effective, so there is a bigger reduction of cost for us on not paying software to companies that do it professionally. Of course, this requires a lot of expertise to run these tools in-house. We have this in the team, as I said before. We don't have dedicated resources to do this, so we share between the team this. And another important feature is the extendability of the support. So you need to be able to support your own code. We have various people that have coding knowledge inside the company, and we try and collaborate with them to define new features that we need to extend these tools. And of course, having access to the source is something that helps us greatly in this. Okay, let's talk about the network monitoring. So what we choose for network monitoring is something that a lot of people do. It's Opsview and Nagios in general, and NMIS. This helps us with sorting a lot of the alarming part, so everything that regards alarm on network devices and stuff like that. And NMIS allows us to have an overview split per router, or a cumulative overview of all the utilization of our network interfaces, for example, the utilization of the CPU, RAM, and all the critical factors that our devices have. Of course, we use a lot of custom RRDs graphs, like I think a lot of you do, especially for aggregating, for getting a view of aggregated traffic statistics. This is proving quite hard for us at the moment, because with the fact that having hundreds and hundreds of 10G interfaces, stacking graphs is giving us some limitations, but I will talk about it at the end. And we have a lot of scripting, of course, to monitor specific aspects that we want to monitor, for example, the state of BGP and stuff like that, the state of the IGP and various other things. Okay. Capacity planning, as I was saying, is something that is critical for our infrastructure. We make a use an extensive use of NetFlow. We choose to use PMACCT as collecting software for NetFlow in combination with a MongoDB backend. I didn't make this choice, so if you want to discuss about it, why we choose this, I will point you to the right person that did it. And we have a user interface that is developed in-house that does the type of queries that we need to do. So our focus is on destination IS traffic, so the traffic that we actually push towards the destination. This helps us to improve the performance and the path that we need to have, the capacity that we need to have to a destination IS. Of course, this take to immediate results. For example, the cost reduction that we obtain with this, it's immense because we have a complete view of where our traffic is going, and we can make cost reduction decisions based on the forecast. And of course, the long-term results are measured in the customer response. So what the customer feedback is towards our implementation of the network. I can easily say that over the period of time that I worked at Fibering, the more we used and integrated these tools all together, the customer quality improved greatly. Attack detection, as I was saying, this is based on more or less the same principle. The principle is using NetFlow data to analyze the flows, what is going on in the network. We decided to split the system from the trending system because of size restriction of the hardware that we use. Of course, having a lot of data and having a lot of NetFlow flows, it requires a lot of hard drive space, a lot of RAM, a lot of CPU, and a lot of resources. So we decided to rather have smaller servers distributed around that get flows from the various points of the network. We do single small dumps every 60 seconds, and this allows us to have an immediate view of what is happening into the network. Basically, when some reporting happens or some customer call us or we receive an alarm of our utilization in one of our interfaces, our NOC is able to quickly look into the dumps, the 60-second dumps, and see what are the top sources and destinations of attacks. This lowered the response times in such cases of quite a bit, in the sense that within few minutes, the NOC is able to identify and route the destination IP of our customer that is getting attacked, and this is quite good because it limits it increases the customer experience of other customers that are connected to the same device, for example. And the good thing about NF-dump is that it's very easy to use. There is extensive documentation online, and it's very easy to train even very junior people in our network operations center to utilize it. Overall, I can say again that the customer experience improved because we are able to tackle attacks in very few minutes, and this is something that we are proud of. Of course, the whole infrastructure requires quite a bit of resources and expertise to maintain. Like I said before, it requires a lot of resources on the hardware part of it, and it requires expertise because, for example, our hard drives are running full almost every day, and we have in place measures to reduce this, but it requires human intervention most of the times. For the network devices configuration backup, we choose a path that is a bit different of generally what other people do. We decided to use Oxidized and GitLab in integration with GitLab. Oxidize is a new tool that aims to be a rancid replacement. Rancid is a very old software that has some limitation that Oxidize tries to overcome with the new structure of the code that it has. The design team, our design team took part to the development of Oxidize and is actively involved into the maintenance of the software. You can look up the code of Oxidize and find it on GitHub. It's Ruby code and it's open source and maintained by a community. So if you want to contribute to it, it would be greatly appreciated. Octilize is built with a few ideas in mind. The main idea is that it needs to be easy to integrate with the internal systems, so it has background mechanisms like a RESTful API, HTTP, an easy HTTP interface that can be easily converted to JSON to integrate with your own systems. And in general, the fact that it's run by a few guys that are doing this voluntarily allows you to have your features implemented in a very small amount of time. So you can always open a pull request for your own code or open an issue for something that you want to see implemented, and this will be implemented within days in general. Oxidized can use GitLab in integration for storing the configurations. This gives us the advantage of having an extensive view over HTTP of the updates that every device has to the configuration. So if somebody changes something in general, the device will get pulled in a period of time that you set into your Oxidized software. And you will see a very nice aggregated view, GitHub style, but in GitLab is a private repo, where you can see the updates that happened to the configuration in the last hour. And you can use the function of git blame to see who did the update. So if something going wrong in the network, you can always track down who did the last update to the configuration, which for us, it's very important, accountability. Of course, an added benefit of using GitLab is that you can store your other repository for free. So it doesn't necessarily have to be binded only to Oxidized, but you can host whatever other repo you want to host on it, like it's a GitHub-based private for your company. Some future consideration have to be done, especially regarding the scale that our tools are getting. RRDs, as I was saying, is not enough anymore for us. We are not able to stack any more graphs, for example, in our total aggregated graph, because we exhaust the file descriptions on the file handles on our Linux boxes. This is a kernel limitation that can be overcome, but it probably requires us to look into a longer-term solution that, for example, could be use a time series database. I don't know if you're aware of it, but InfluxDB, for example, and time series database are taking a lot of place recently because of the easy structure and easy utilize that they have. InfluxDB is basically MySQL implementation for time series databases. So you can use MySQL-like syntax on a set of data that is time series data, so like values associated to a time, and you can do minimum, maximum functions and averaging. Another thing to look at is extend Oxidized scripts to our needs. Oxidized script is another small software that comes with Oxidized. It's a library or also a command line tool that allows you to connect to routers and display information from the router, I don't know, a show configuration or a show BGP summary in a very easy way. It's a few lines of code, and you can get the output of the router and then parse it as you prefer. Of course, we already use it, for example, to monitor BGP state from live machines without using SNMP. More for, I would say, for validation of SNMP data. And it's easy to use, so we will look into this for the future developments. We are looking into various log visualization tools. They are under evaluation from another department from our NOC, from our network support. So I don't know much about it, but I know that it is surely something very important for us because the amount of alarms and the amount of things going in our logs is massive at the moment, and having a simple syslog piping to an IRC channel or to a single file is quite suboptimal. We are looking into hire software developers to enhance our tools, especially for the netflow interface, for all the command line tools that can be used to monitor status or to help our NOC to improve the quality of their work. It's much needed, and we're surely looking into hiring new people for this task, dedicated people for this task, because as I said, at the moment it's all on the network design team and on the network support team, so it's quite bad. There is some early discussions on the development of a new NMS. This is happening in collaboration with other parties in the industry. We talk with people from TDC, from NTT, and various other companies, and the need seems to be starting to take some real results, in the sense that we did the 3 discussions for now, and we put down a set of requirements that are not covered by any other development, by other NMS. We looked at Opsview, we looked at PMACCT, and in general, they're all quite incomplete. And the last consideration is automation. Of course, everything will run smooth towards automation, and I think that our job as network engineer will head in that direction more and more. So it's mandatory that we will start to use more and more resources towards that direction. Okay, I think I can pass back the ball to Bart for the conclusions.
Yeah, so basically the conclusions are that with a pretty small team, we can run a pretty efficient global network. The whole team of design and network engineers is less than 15 people. They not only run this global network, but they also run and support customers on some of the internal networks of our hosting companies, especially LeaseWeb in the various countries they operate in. But the challenge is really to find people who understand programming, scripting, but also understand networking. And those animals are not easy to be found. That brings us to the end of the presentation. I guess there is some time for questions. If not now, feel free to visit our booth upstairs. For those who consider peering at the Amsterdam Internet Exchange, we have some special offers. And for those considering to spend a few years in Amsterdam as a design engineer or support engineer, we do have some open vacancies. So please stop by and have a chat. Thank you very much for your attention so far. Any questions?
So if there's no questions, thank you for your lecture.
Thank you.